as you can see on your screen, this is a problem from Gauss law given in JEE Advanced. So let us try to solve this problem. So before we jump into the solution of this problem, what are the concepts that you need? The first concept that you need is an understanding of electric flux. What is an electric flux? It is basically the number of field lines passing through a certain area. So this is the definition of electric flux, as you know, and by Gauss law this is equal to net charge enclosed by the Gaussian surface divided by permittivity of vacuum, which is epsilon naught. So basically flux means it is the number of field lines, right? Now another concept that you need for this particular problem is that the concept of spherical arc. Now in many books you will see that this spherical arc concept is bypassed through solid angle. Now at your level you don't need to know the solid angle concept. What you need to know is the idea of spherical arc. What is spherical arc? So suppose if this is a sphere and say this is a radius r, you join these two points of the circumference and you draw a vertical line. The vertical line makes an angle theta with respect to both the radius. So you will have an arc on the sphere. It's a dome shaped spherical topmost part of the sphere. So it is in 3D. What is the area of this spherical arc? The theory says that the area of this spherical arc is equal to 2 pi capital R square into 1 minus cos theta. Now before we jump into the solution of this problem, what you need to know is that what is the flux value passing through that curved surface. So suppose if I keep a charge capital Q at the center, what will be the total flux through the sphere? The answer is Q by epsilon naught. Now what is the flux density? Flux density means what is the number of field lines passing through per unit area. That's going to be phi divided by 4 pi r square. So that will be Q by 4 pi epsilon naught capital R square, right? This is the flux per unit area. So how much flux will go through this much area is that flux density multiplied with this area. So the number of field lines that will pass through the spherical arc is Q by 4 pi epsilon naught capital R square multiplied with 2 pi r square into 1 minus cos theta. That gives you flux through the spherical arc as Q by 2 epsilon naught into 1 minus cos theta. So this problem may come in CBSE school exams or competitive exams also. So this is a very interesting idea that you must know. So what you can do is that then you can bypass the solid angle concept. Okay. Now let us come to this particular problem. The problem is saying what? The problem is saying that there is a charged shell, that means a hollow sphere of radius capital R. Okay. It carries what? It carries a charge capital Q. So what is the total flux through this sphere? It's going to be Q by epsilon naught. Now see, in the problem they are saying that given phi as the flux of the electric field. So given phi as the flux through the electric field, phi as the flux of the electric field through a closed cylindrical surface of height h and radius r, and with its center same as that of the shell, that of the hollow sphere. That means the cylinder and this hollow sphere are concentric. Okay. Here center of the cylinder is a point on the axis of the cylinder which is equidistant from its top and bottom surfaces. So which of the following options are correct? So before we jump into the options, try to visualize that there is a sphere and now there is a cylinder passing through the sphere. And the center of the cylinder and the center of the sphere, they coincide. So these are the options and we have to check which one are correct. So for the first case, what the first case is saying? The first case is saying that if h of the cylinder, that means the height of the cylinder is greater than 2r. What is 2r? 2r is the diameter, right? So the height of the cylinder is more than 2r. That means its height will be more than the diameter. and the radius of the cylinder is also greater than the radius of the sphere. That means the cylinder will be something like this, right? Okay, from my diagram the center is not coinciding, so I'll just try to redraw again. So try to have an approximate idea, something like this. This is the cylinder. The center of the cylinder is here, and here is the cylinder. Its h is more than 2r, its radius is also more than the radius of the sphere. So that means the sphere is now inside the cylinder. And what are the field lines? The field lines, the flux are going out of the surface area, right? So what will be the flux now through this cylinder? Because the entire charge capital Q contained by the sphere is inside the cylinder. So this means flux through the cylinder, which is phi defined, that is going to be Q by epsilon naught. So option A is correct. Okay. Now let's go for the second option. Second option is saying what? H is less than 8r by 5. What is 8r by 5? It is 1.6r. That means the height now is less than 2r. That means the cylinder is now smaller than the diameter of the sphere. And also see the radius. The radius is 3r by 5. That means the radius is also less than the radius of the sphere. So how the cylinder will look like? The cylinder will look like something like this, right? It's a concentric. The center coincides with the center of the sphere. So the cylinder is inside. So the charge is outside. So inside the cylinder there is no charge. The charge is outside on the circumference of the sphere. So what is the flux through this cylinder? That's going to be 0. And option B is also claiming that the flux through the cylinder is going to be 0, right? So option B is also correct. Now let's go for option C. What option C is saying? Option C is saying, so for this option I have to redraw, so I'll just erase the diagram. So option C is saying that H is now less than 2r. So I'll draw the sphere. Now, H is not less than 2r, it is greater than 2r. And radius is 3r by 5. That means the radius is now smaller. It is 3r by 5, it is 0.6r. So how the cylinder will look like? The cylinder will look something like this. Is it understood? H is more than 2r, but the radius of this cylinder is equal to 3r by 5. So what you have to find out? The flux through this sphere. Now see, I'll divide this sphere into two segments. One, the two reds. The one of the east side, another is the west side. What you can see from this diagram, that these charges which are outside the cylinder, their flux will obviously be radially outward, right? They are going radially outward. So these field lines are not going to pass through the cylinder. That means the red surfaces are not going to contribute anything to the flux of the sphere. But if you consider or you see the diagram, the northern part of the sphere and the southern part of the sphere, their field lines, you can see easily that they pass through what? They pass through the cylinder. So that means those two fluxes have to be calculated, and flux is a scalar quantity. So you find out the flux of the upper sphere, that purple color, and the lower purple color, right? So how to do that? So for that I'll use this concept, okay? So what I'm going to do is that I'll join the center, I'll connect the radius. So this is the radius of the sphere, which is capital R, but the cylinder is now having how much radius? The cylinder will have a radius small r, and the value of small r according to the problem is 3r by 5. So small r equal to 3r by 5. So if small r equal to 3r by 5, this means this particular segment, the red one, will be how much? It is going to be 4r by 5, right? So what will be this angle? Theta. Now what will be the cos theta? The cos theta is going to be base by hypotenuse. That means it's going to be 4 by 5. So what is the flux through the purple spherical arc? That's going to be phi equal to Q, capital Q, by 2 epsilon naught into 1 minus cos theta, and the value of cos theta being 4 by 5. So we'll put the data here. So how much flux I'm getting? It is coming as Q by 10 epsilon naught. So this is the flux that is passing through the upper hemisphere. So that means by symmetry, the lower hemisphere will also have this much flux. So total flux is how much going to be? It's going to be Q by 5 epsilon naught, which is option C. So A, B, C are all correct. Now let's go for h greater than 2r, but now the value of small r being 4r by 5. So if value of small r becomes 4r by 5, so you can easily understand that if small r equal to 4r by 5 is just the complementary case of the previous case. So if small r becomes 4r by 5, then what will be the value of this red line now? The value of this, इसका value कितना हो जाएगा? इसका value हो जाएगा 3r by 5. तो इसका flux कितना आएगा? The flux is going to be q by 2 epsilon naught into 1 minus cos theta. But now what will be the cos theta value? 3 by 5, which is going to be q by 2 epsilon naught into 2 by 5. So cancel it out. It is coming as q by 5 epsilon naught. So the flux to the upper surface, the upper northern part of the spherical arc is going to be q by 5 epsilon naught. So what will be the flux to the lower southern part? Is going to be same. So what is the net flux? The net flux is going to be the summation of these two fluxes, because flux is a scalar quantity. So the total flux will become 2q by 5 epsilon naught. But option is saying what? Option is saying that it is only q by 5 epsilon naught. So this means option D is incorrect. So I hope you really liked this discussion and you learned something and you try to apply and implement this concept in your numerical. Thank you for watching. See you in the next video. Tata.